Hi, welcome to one and all. Next, we will be discussing Legendre symbol and its properties. We have already studied about the quadratic residue mode P and quadratic non-residue mode P. So this is in continuation to that. Let us see what is meant by Legendre symbol. Let P be an odd prime if does not n is not congruent to 0 mod P, that is n is not divisible by P. We define the Legendre symbol as follows. We read it as n over p, the Legendre symbol n over p. Usually we use n. This is also read as n divides p, but for Legendre symbol we read it as n over p. So the Legendre symbol n over p is 1 if n is a quadratic residue mod p, and minus 1 if n is a quadratic non-residue mod p. So this is the definition, and if n is divisible by p, then we call n over p. The Legendre symbol n over p is 0. So n Legendre symbol is non-zero only when n does not divide by p. So n over p is 1 if n is a quadratic residue mod p, and minus 1 if n is a quadratic non-residue mod p. Now we will see some of the examples. Before that, it is usual that some authors use n by p to write n over p, or this is also written as read as n over p. So others used to write like n by p like this, as well as n divides p in this form, in these two forms. So we will be preferring this form because this is given in the textbook throughout. Next, we will be discussing about some examples of this quadratic Legendre symbol. Let us see how this Legendre symbol works. Suppose you are having a 1 over 5. 1 over 5 is 1, that you know. 1 over 5 is 1. Why? Because 1 is a Legendre symbol, 1 is a quadratic residue mode 5. 1 is a quadratic residue mode 5. 2 is also a quadratic residue mode 5. So in case of quadratic residue, we write 1. So that is why it is 1. And same in the same way, for 4 is a quadratic residue mode 13. So 4 over 13, the Legendre symbol 4 over 13 is 1. Similarly, 1 over 13 is 1, 3 over 13 is 1, 9 over 13 is 1, 10 over 13 is 1, 12 over 13 is 1. Because this is because for 13 the quadratic residues are 1, 3, 4, 9, 10, 12. So similarly we see that 2, 5, 6, 7, 8 and 11 are quadratic non-residue. So in that case, if a number is a non-residue, quadratic non-residue mode p, then it is minus 1. That is why we have written 2 over 13 is minus 1, 5 over 13 is minus 1, 6 over 13 is minus 1, 7 over 13 is minus 1, 8 over 13 is minus 1, 11 over 13 is minus 1. Now if the numbers, the 12 over 3, this is, in fact, this number comes after 3, still 12 over 13 is 0, and 14 over 7 is also 0. This is because 12 is divisible by 3, here 14 is divisible by 7, 22 is divisible by 11. So because of that, this is 0. Now let us see some of the properties of Legendre symbol n over p. Now discuss let's discuss some of the properties of Legendre symbol. The first property is that n over p is equal to 1. This is clear because this n over this 1 is a quadratic residue for all the numbers odd primes p. 1 is a quadratic residue for all the primes p. That is why we have seen that 1 over p is always 1, because 1 is always the quadratic residue mode of p. So next one is m square over p is 1. The Legendre symbol m square over p is 1. To prove this, we need one concept, that the multiplicative property, because you know this, this is multiplicative, that we will prove later. Anyhow, m square over p can be written as m square over p can be written as m times m over p. M times m over p can be written as m over p times m over p. So now we have to see, if we take m over p is 1, that is if m is a quadratic residue mod p, then it will be 1, the Legendre symbol will be 1. In that case, this will be 1 times 1, so 1. So m over p over times m over p is 1, that is m square over p is 1. There is no doubt in that. In case m is not a quadratic residue mod p, in that case m over p is minus 1. That is, if we take m over p is minus 1, then in that case also minus 1 times minus 1 is 1. So in that case also, the m over p is m square over p is 1. So in both cases, this m square over p is 1. Next, we will be discussing about um, that Legendre symbol n over p is a periodic function of n with the period p. N over p is a periodic function of n with period p. This is what we are going to prove. If m is congruent to n mod p, suppose if we take m is congruent to n mod p, then clearly we know that if m is a quadratic residue mod p, then the same will happen for n also. If m is a quadratic residue mod p, then n is also a quadratic residue mod p. And if m is not a quadratic residue mod p, then n is also a not a quadratic residue mod p. So this is in the reverse order also. That is in the opposite way also. So this means that if either m and n are both quadratic residues mod p, or m and n are both quadratic non-residues mod p, that means both will take the same value. So both will take the same value means the Legendre symbol m over p is same as Legendre symbol n over p. Now we can see that if m is congruent to n mod p, this means that n can be written as kp plus m. That is, m is nothing but a p multiple times m is n. N is a m plus a multiple of p. So from this itself we can see that this m and n are periodic. That is, n repeats after some p multiple of came after a multiple of p. That is m plus p. If what is a periodic function? Periodic function is that function which is repeated after a certain period. So this can be written as n is m plus p, or m plus p plus p, m plus p plus p plus p, like that. So in that way this function is periodic. So whatever is having Legendre symbol m is having the same Legendre symbol is n is also having. So in that case this is repeated. So the periodic function of p, the period p, is a periodic function. So that we have proved it. Now let us prove n raised to p minus 1 by 2 is congruent to plus or minus 1 mod p. This is what we have to prove. To prove that this is congruent to plus or minus 1 mod p. This is not equal, it's congruent. We have already studied a Fermat's theorem, that it is Fermat's theorem, that n raised to p minus 1 is congruent to 1 mod p if p does not divide n. P does not divide n, n raised to p minus 1 is congruent to 1 mod p. So now we will take this part. So when you take 1 to this side, we have n raised to p minus 1 is congruent to 0 mod p. That means that p divides n raised to p minus 1 minus 1. P does not divide n. Now since n raised to p minus 1 minus 1 can be written as, because if you take this as some root square like that, in that case is n raised to p minus 1 by 2 minus 1 times n raised to p minus 1 by 2 plus 1. So now it follows that this can be replaced here. So n raised to p minus 1 by 2 minus 1 times n raised to p minus 1 by 2 plus 1 is congruent to 0 mod p. which implies that either this is content to 0 mode p or this is content to 0 mode p. So from this itself we can write it as n raised to p minus 1 by 2 is content to 1 mode p, and n raised to p minus 1 by 2 plus 1 is content to 0 mode p. That means n raised to p minus 1 by 2 is content to 1 mode p, or n raised to p minus 1 by 2 is minus 1 mode p. That means n raised to p minus 1 by 2 can be plus or minus, oh sorry, here it is plus or minus 1 mode p. N raised to p minus 1 by 2 is content to plus or minus 1 mode p. I hope you have understood these properties very clearly, and next we will be discussing a theorem that we will be discussing in the next video. Hope you have understood this concept. If you have any doubts, you just ask me by messages, and if you have any queries, you can ask. Thank you very much for your patient listening.